Hello and welcome to Busy Plugin Developers episode number 4. The first one in this year, and we are happy to have a guest speaker with us today, Dmitry Kandalov, who will talk about his LivePlugin. My name is Jan Sebron. I'm working as a developer advocate in the IntelliJ SDK team. So we take care of everything around plugin development for the IntelliJ platform, and that, of course, is today also our topic for today. And the whole thing is a bit in the scope of what kind of alternatives do actually exist if you want to extend your IDE at runtime. And one of them, the LivePlugin, we are going to take a closer look at today, and Dmitry will show what's possible using LivePlugin and show us everything in action, and also talk about a bit about the backgrounds and hopefully also some technical details. But I also want to point you to the page on this slide, which links to the SDK documentation, where we list a couple of other techniques and alternative approaches if you don't want or maybe don't even need to really build a full plugin. So make sure to check out this page as well. And with that, I really want to hand over to Dmitry Kandalov, our speaker today. He's also the developer of LivePlugin. I think it exists for more than 10 years, maybe even much longer than 10 years. I don't really remember. It's a quite popular plugin actually on the marketplace. If you have any questions during the stream, please don't hesitate to ask them in the chat, in the live chat, and we'll try to answer them right away, or we might collect them for the end when Dmitry can take some questions after his presentation. So Dmitry, the stage is yours. Thanks for joining.
Jan. Thank you, Jan. Feel free to ask questions while I'm showing slides. So as you can see from this slide, this is obviously about LivePlugin. And as you can imagine, LivePlugin is on Marketplace. This is what it looks like there. And as also you can imagine, it's on GitHub, it's Apache 2 license. And as Jan mentioned, I've been supporting it for quite a while. So the initial version was written in Java, it supported just Groovy. Then I added Clojure and Scala, and later on I removed Clojure, Scala, and moved to Kotlin instead and rewrote the whole plugin in Kotlin. So I'll demo it using IntelliJ and Kotlin, basically. There is an obvious question of why would you do that, right? Why not write plugins the normal way? And the reason is that, at least my motivation was minimal setup. That I don't want to create a separate project just to write like 2 lines of code. Another thing is that I don't want to restart IDE every time I change like few lines in my plugin and so on. It's just faster feedback loop. And the other idea was to have somewhat simplified API for IDE. So some APIs are quite nice in IntelliJ, but some like a bit more sophisticated. But these are like 3 main things I wanted to improve. And I don't claim I have improved all of them massively, but that's the idea. And to just show what it is instead of showing slides, I'll do a quick demo. And here I have IntelliJ in presentation mode. And just to highlight, this is a Gilded Rose project. So it's a code cutter, like code exercise, which has nothing to do with plugin development. So if you go to IDE settings and then like install LivePlugin plugins, as you probably know, then you will get this tool window called plugins. And inside there, initially, I'll actually just show what you can do. You can press plus, and then you can go to Kotlin examples and click, let's say, hello world. So there is lots of code and like text which is supposed to guide you, but I'll just do it from scratch. So the simplest thing we can do is call this function called show. And maybe let's import this. So if I run this, I can use this button in the panel there. So if I press play, it will kind of run the plugin and it shows the message hello. This message appears in event log as well, so you can see it's a real event in the event log. In the latest versions of IntelliJ, like the one which just came out, it's a notification, so it will look slightly different in the latest version. So like, yeah, that's some code which runs a function. But the interesting thing here is that there is some context. For example, from this you can get a project where project has type of project question mark, which is an object from IntelliJ API. So what I can do autocomplete, and I can get lots of things here, like find a base path, or for example, name. So if I run this now, it shows me a notification with the name of the project, which is Gilded Rose, as you can see here in the project view. So that's like real code which can access objects in memory of IntelliJ. It has a few other things you can see inside the context. So as you can see, it highlights Kotlin. It knows how to import function from LivePlugin. It can autocomplete on the object which represents the class inside IntelliJ. You can also use navigation, so you can jump, for example, to definition of the show function, and it jumps to the source code of the show function, which is bundled with LivePlugin. And so you can see how it's actually implemented. It's not particularly sophisticated. I'm not going to show it, but it's basically a wrapper around IntelliJ API, so it's like a thin wrap around it. Then I can also, for example, jump to the project class. Unfortunately, it doesn't come with source code, so this is all decompiled code. But nevertheless, you can kind of see what's going on there. And we can also jump to this project variable, and we can see that each script, it has like few variables in the context. So one is ID, startup, project, plugin path. And the other interesting one is plugin disposable, which is kind of important to know for life cycle of the project. So disposable, it's a standard part of IntelliJ API, which runs when the plugin is unloaded. So let's call it. So what I'm doing here, I registered a callback. When plugin disposable is disposed, it will show a message disposed. And here I'll say message created. So if I run this now, it shows created, and then in the tool window, I can press this like stop button, which unloads the plugin, and then it shows disposed. So yeah, that's kind of the life cycle. So if I run it again, it shows created. If I press this button, it's like reruns. So if I press it now, it will like dispose the old instance and create a new one. So that's the idea here, that you can clean up resources or like unregister listeners by using this disposable. Obviously, if I type something incorrect, the LivePlugin will kind of blow up, say this is wrong. And just to show also, this is all like real code. So if I throw an error here using Kotlin function, let's say I call it foo. If I run this and then unload, we should see like ID telling that something went really wrong. It blames LivePlugin, but it's not really LivePlugin fault. But you get the idea that you get all auto-completion, syntax highlighting, only if your IDE supports Kotlin, of course. But that's kind of hello world for the LivePlugin. So I'll switch back to slides. So what we have seen is that you can run it in any project, you get syntax highlighting, you have some context variables, and there is plugin disposable, which is used in many IntelliJ APIs. So that was hello world. And here are like few slides to kind of explain in a bit more details how it actually works, because it might look a bit just magical. So obviously, if there is some Kotlin code, there will be Kotlin compiler. So on the right-hand side, this big square is representing the whole Java virtual machine in which IntelliJ runs. So LivePlugin comes with its own compiler for various reasons. Mostly, just it has its own compiler. It takes this input source code as a Kotlin file you've seen, it compiles to binary. Then inside IntelliJ, it creates a new class loader, which represents this instance of the of the plugin. Then that plugin class loader loads the binaries from the disk, and then IDE can register them, or like IDE can load this class and do something with it. So that's like the basic way to load one plugin. Then obviously Kotlin compiler needs to know about JDK, IntelliJ jar files, and libraries which plugin uses, so that must happen there. And the same must be happening at runtime, so the IntelliJ will know about JDK and IntelliJ jars through class loaders hierarchy, and plugin class loader will know about it, libraries and dependencies on other plugins. So it's a bit more sophisticated. So once you unload the plugin, what happens ideally through plugin disposable, you make IDE forget about all references to your plugin class, and that means that Java virtual machine can unload your class and class loader, so they all kind of just disappear. So that's why, in theory, it shouldn't have any memory leaks. And then like we can forget about this binary, we modify text file and we repeat the process and kind of load everything into IDE. So that's the life cycle for this. And as an overview, there is plugin disposable, there is compilation, and each plugin execution has its own class loader. So that's the life cycle. And now I'll like move on to more demos. Essentially the whole talk will be demos, and I'll start with something like notifications, because LivePlugin, like there is an obvious question like, oh, could you debug your plugins once you wrote a bit more code? Could you debug it? And it's not that easy, because you need to attach debugger through the process in which you're running. So that's kind of interesting. So as you have seen, there is the basic function which is called hello. So I'll run it again just to make sure things run. Oh, ran too many things. I'll comment this for now. So there is hello basically, and it works fine until there is too much output. Oh, so in the first place, you can also have a title. So you can see parameters here. For example, some title, and it kind of looks nice. It's all part of IntelliJ. IntelliJ formats this. You can choose notification type and other things. One thing I didn't notice is that you can actually configure what happens. So you can go notifications, settings, and you can see these notifications, they appear into LivePlugin. So you can disable balloons, for example, if you don't want to see them. So title is fine, but if you have, for example, a big output, I'll just create a random exception, and then I'll have stack trace to string. So that's like a lot of output, doesn't quite fit in, doesn't look that nice. So for that reason, LivePlugin has this simple way to show things in console. So if I show the same thing in console, it will be slightly nicer. So you can see it shows it like in the run console. That's the other way. So the short story, like I would use show for something simple, for large output, show in console. The other problem is like, what if you have lots of output, and the actual simplest answer is to use println. It's not obvious, but I'm not going to show it, but it basically goes into IntelliJ console. Well, actually I could try. Oh no. So basically it goes into IntelliJ console. There is also a logger, which is part of IntelliJ API. And as you imagine, you can do debug or info, but like println works, it goes into the same file. So these are equivalent almost. So this is in terms of like basic notifications you can have. Then there are other things which you can have. They can have some basic dialogues. So this code here, it literally is just using IntelliJ API. So you can see it's common IntelliJ Open API UI, show yes, no dialogue. And this is the dialogue. It's exactly the same code you could see in other parts of IntelliJ. So it's like, is this a question? No. So it's like a sad cat. Yeah, so basically you can call code like any other plugin, or get some basic input like this. So if I say foo, it prints it out, so just showing that you can use normal dialogues. And that's kind of it. That's the way to kind of figure out what's going on with a plugin. So I'll unload it and switch to a couple slides. So yeah, as a summary, I would use show by default, show in console for large output, and just print if it's a loss of output inside some inspection. And yeah, that's the basic, how you can figure out it. But the most important thing, the simplest, like the lowest hanging fruit you can get with plugin development is by using actions, really. Action is part of IntelliJ API. I would describe it as a function, like stateless function, which receives an event. Like in this case, I'll just format this a bit better. Put arguments on separate lines. So in this case, we have an action with ID called show project name. It has a keystroke, and it receives an action event, which is the context in which event is evaluated. And then it produces side effect. So just to repeat again, action is a stateless function which produces some side effect, and it can observe the state of ID via an action event. That's how I would interpret this. So let me run this. So when I run this code, nothing happens, but then I can go like to help, find action, and I show project name. So you can see the top line is what the plugin just created. So if I press enter, this action runs and it shows gilded rows. So I can also use shortcut Alt Shift dot, so it shows more of these notifications, which I'll close. And there are a few things here. So like one is action ID, that is keystroke. You can also specify, as you can see here, action group, for example, action group ID. And one thing I can do, tools menu. If I reevaluate it now, I can go to the tools menu, and at the bottom there is show project name action. So if I click on it, it works. The interesting thing here is like, if I unload this, if I press like unload plugin, you can see that it disappeared from the tools menu. It's a little bit tricky in terms of like this function, because you cannot see any plugin disposables around, but there is one. The reason, like the way it works, maybe I made it a bit tricky, is that this function, register action, is an extension function on LivePlugin script context. And LivePlugin script context, if I navigate to it, is this object, if you remember it, with these 4 fields. One of them is plugin disposable, so I'll go back now. And here, this register action actually passes plugin disposable. So when you unload the action, the plugin disposable like removes the action. Yeah, so that's what is happening really here. Also, as you can see, register action comes from LivePlugin, but it's again just a thin layer around IntelliJ APIs. So I imagine if IntelliJ like has had really nice APIs for registering unregistered actions, then like I wouldn't need any of that. And yeah, let's try it again. So it's like appears in this menu now, and there are a few menus which I kind of saved as constants. So one of them is editor pop-up. So if I evaluate, it appears here now at the bottom. See, so it's kind of pretty cool. You can insert your action anywhere, include most panels. The only tricky thing is like figuring out what's the ID of all the panels. This might not be trivial. You might need to look at source code and so on. So what I showed right now is like the whole action is basically just lambda here, but it doesn't have to be. So let's like refactor this code a bit. And there is, I'll create a class called show project name, and it will extend an action, which is, maybe you didn't see, but it's a part of IntelliJ Open API. So it's like part of IntelliJ API basically. So it's not part of LivePlugin. And this is like a real object, so we can implement action performed called event, and that's essentially this thing here. So I copied this code. So instead of the lambda, we can actually specify the action and just create show project name. So that's the same thing. It still works. I just use the shortcut. So you can see that you don't have to use necessarily API. You can like do it yourself, basically. Yeah, so you can also, inside actions, you could call other actions. So to do that, one way also to find other actions, to use Action Manager. This is how LivePlugin does it basically. It registers action, so there is this function, register action, unregister action. And you can also like find actions. I think it's called get action, and I think it's this get action ID list, and it will have a prefix. And action ID is like if I search for bookmark, I think it should show something interesting. So you see it shows lots of actions, IDs which start with bookmark, for example. So that's how you kind of figure out what to, which actions exist, and then you could get hold of one of them by using, for example, Action Manager, get action by ID, and invoke it with the current context. So if you get an action, I'm not sure about bookmark, but yeah, you can get an action ID and invoke it. That's like one way of finding actions, just to list them all. The other way would be to, for example, use macros. So here, like if you don't know, in main menu there are edit the macro, so you can start recording, then stop, and then you can go and edit macros. So here I did something, and I did build project in Kotlin, and the action ID is compiled dirty, so that might not be obvious. So let's try this. I'll do this, and I'll show it if there is an action. So, oh, this didn't work. Compile, not compiler. Yeah, so now we get an actual action which we could invoke. So that's roughly how I figure things out. So we can say this action performed. It might not actually work straight away, but no, it does work. So you see it's building my project now. So this way it's kind of a bit more interactive way of doing macros. Like you can script your macros. So that's the main idea here, basically. Okay, so this was a bit long, I guess, but I'll show more things. So there is the next thing related to actions is action groups. And I'm gonna just show code bit by bit here. And there are a few things here. I think the first thing is that action group is like a composite pattern for action. So action group is a group of actions, really. So here I'll evaluate this code and kind of show it later. So here we have an action group, I think, which is an action. It could be an action here. So yeah, so you can see this is action group is just an action, and then down here we just register it with the same keystroke, an action, and we put it in the tools menu. And the action group here is a set of actions, so it's easier to see, I guess, in the menu. So it becomes kind of a pop-up thing here, right? So it's just a few items there, or I can use the shortcut, and then it runs still the wrong thing. Not sure why it's not like showing pop-up, but probably should. So anyway, so you can see that there are a few actions. Here's one action at the top is to open URL. So this way you can just have bookmarks in your browser. So that's just going to open LivePlugin. Then the second action here is called run script. And what it's doing is a bit interesting because it calls this function run in background. It has this name of, it has a task title. It's easier to show, I guess. So run a script. So it does something in the background. Doesn't show too many details in presentation mode, and then it will print output, so it's just some results of the script. So what it's doing is running this script, which is like these 3 lines, and it uses plugin path to run hello sh, which is right here in the folder, and it does just some bash command with hello. The interesting thing here is that it runs it as a background task. So whenever you invoke an action, it executes your code on user thread. So you should not do like thread sleep here, because you will just freeze user interface. That's why there is this run in background task, which again wraps some IntelliJ APIs to do it in the background. The other interesting thing is how you can use just run this function just to run some shell script. And yeah, I guess that's pretty much it. Also in the previous section, I didn't mention that the actions, there is a difference between when you invoke this shortcut, for example, here, and you get one event. So maybe if I move it into somewhere, well, maybe I'll try it later. Anyway, so then the final thing here is that show that you can also use some libraries from inside these plugins or scripts. So here the example is that I can use HTTP4K to do a request to DuckDuckAndGo. So I can run it and we'll see it does HTTP request. Admittedly, this is not ideal because it's not doing it in the background. It's doing it on UI thread, but it's fast enough in this case. So you can also see that these notifications, they do some basic HTML rendering. And the reason it works with HTTP4K is because I added this instruction, so add to class path and then its plugin path, and it picks up all the libraries from the lib folder. So it does request, it creates a client, which is based on HTTP, does a GET request, gets a response, and then gets a body as a string. And finally, there is special action, which is a separator. As you can see in the menu, it looks something like there's just a line. And the last line is action, which opens the current file. So if I close this, I'll close everything and goes to the tools menu, go to the tool menu, I can open plugin KTS. It opens the menu. So the idea here is that if you have some kind of menu, you don't need a special separate config file like some JSON or XML to configure it, because you can use your source code as configuration basically. So these are the ideas, and yeah. I'll switch to slides. So those are the takeaways. I guess one thing I didn't mention is actually everything you do in IDE, not everything, most things, are actions. So when you move cursor up, it is an action. An action is a stateless function. It can be registered, unregistered, and action groups are actions as well. So the next thing is about editing text, because this was like a little bit abstract, and I guess if you are doing code editing, then it would be more interesting to be able to kind of extend IDE in a way that you can do something with actual source code. So to illustrate this, I'll use again some code. I'll use action, which will be doing randomizing case in the editor, because there is uppercase and there is lowercase actions like these ones. But then why not have random case? So let's try. I'll evaluate this whole code, and now if I go to the cursor, let's say to here, I can do lsheet dot, and it kind of does the randomized case. And I'll show a few things. So first place again, it just registers action, random case. Then it has this shortcut. Could be a dot as well, I think. So that works too. Yeah. Then it takes an event, and from the event we can figure out the current document. So actually, to show that you don't need necessarily to have actions and you can do something a bit more interactive, it might be worth trying something like project, and then we can get current editor. So project is nullable, and the current editor we can get a caret model, for example, one, and then here we can say move to offset, and I'll do, there's now 100. It all needs to be So if I evaluate this code, you can see the cursor jumped because I'm accessing current editor and making the caret move. There are other things you can do. So you can just explore this, right? So for example, there is a selection model, and on selection model, I can just autocomplete to something. I think I can sets the range to select or get selected text. I think I like add selection. No, selection listener. Yeah, there's set selection from offset to 100. So yeah, this just does the selection. So that's like another reminder of how things work. So when you run code inside LivePlugin, it compiles it in the background, but then it actually evaluates everything you see on the screen on the event dispatcher thread, also called UI thread. That's why it's a safe thing to modify everything in the editor. But what I'm showing here is that actually it's okay to kind of experiment just like that. That's what I sometimes do. So there is current editing. In the current editor, there is also current document. So I could actually just get the source code of the document and just show it. So it doesn't like, it should be not null. So I can get the source code of the current file here, right? And I can also modify the current document. So sometimes this is an approach to kind of maybe find a file, start modifying text in a file which you have in a split screen or separate tab, and improve the code, and then put it into action. But here I'll do it in the action. Maybe I'll do it bit by bit, just to show it how it all works. So I'll keep the beginning here, I guess. So let's say we have this, and we want to just show document. So there is a check for document to not be null, and the reason is that if I run it here, this, there is a document here, we can see toString representation of that object. But if I go to, for example, to project view and I press shortcuts, it's null. So that's why there is a check for the document, because you might not have a document in the current context where action is evaluated. So that's why there is this check. Right, then the idea, if from the current document we want to see the text, so we also have the current offset. So let me show the offset, or check that offset works, because let me go to here. So offset is 0. If I go to here, it's 1, and so on. If I go to the end of line 19, end the file like this. So the offset works as well. Then we have offset and we have the document, so we can get all the text and drop everything until the current offset, and then we take the text while it's letter or digit. So we will get all characters to the end of the current word from the current offset where the caret is, and then there will be text before. So what we can just show, basically text before and text after. This should be the current word. And I'm pretty sure, so if I press it now, it's register action. If I go to the top, it's import. If I get to the end, it's empty message, so that's good. It doesn't crash. I'm pretty sure I didn't get it right the first time I typed all this code, because it can be tricky on the edge cases, like between paren and dot or here. So it seems to work fine. So we have the text, and then it's a string. So this whole thing is a string. Then we can map it, and it's just mapping over characters randomly, uppercase or lowercase char, and then join back into the string. And then we can show that this text is fine, so I can reload it. So yeah, this looks quite random to me. That's cool. Then the question is, why not just do document? There is this function replace string, and we kind of know we can do that, right? There is a function, so we figure out offsets of the current word, and why not we just replace it? So if I run this, it kind of blows up, and if I look at the error message, IntelliJ is being helpful, and it says write access is allowed inside write action only C, and then it refers to some classes in its API. So if you go and read the documentation there, formatted. So I think there is this write action class. I don't actually remember exactly how to do that. So I think it's this. Maybe. We'll see. It doesn't like it. No, of course not. Not sure what it wants. Oh, it's a throwable. Maybe it's just an exception. Would be happy, yeah. Let's try that. So it now blows up. And it blows up, that's progress, right? It blows up with a different error message. And it says must not change document outside of command I do transparent action. So the first error, it was related to what I was mentioning before, that you should only modify state of the ID or the document on the event dispatch thread. So that's important to know, because I think it doesn't blow up all the time, but it is important to do it. This is a different error now, because it basically says you need to make your modification undoable, so it kind of appears in the undo menu. And that's just another API. I'm not gonna show it in detail. So there is this function execute command in LivePlugin, so which does it all. So if I do random, it doesn't blow up now, and it also appears here, so I can actually press Command Z and undo this. To be fair, there is already editor action in IntelliJ editor action, I think. Editor action and editor handler, so you don't need to think about this read write, and we could really, I think, rewrite it. I have this code down here, so we could really rewrite this action something like in a way like this, and it should still work. I'll need lots of imports, but you get the idea that it is possible and there is some API. I should probably add it to LivePlugin at some point. I bet imported the wrong thing somewhere. Yeah, that's not a swing caret. That's some OpenAPI editor caret. So this should also work, and there should be random case 2, which should just work. And as you can see, this document here it's not wrapped in anything. So yeah, that's how you can modify text in the text editor. To be clear, this is just a pure text approach, but even with this, you can go quite far. And to summarize, this is what I was talking about. So if you are on user interface thread, also called event dispatch thread, this is where actions are running, then you can read everything, right? So that's the green tick. If you are modifying something, you need to wrap your code into write action on UI thread. But on all other threads, you can do reads, but you need to wrap them inside read action, and you cannot modify any objects from other threads. So these are like threading rules. In practice, if you use the right API, you don't need to think about it too much, but it's useful to be aware of in case you see unusual errors. It's all documented in SDK documentation. So as a takeaway, there is editor and document classes. So editor has all the carets, selection, all these kind of things. There is way more things you can just explore with autocomplete and so on. So you can modify text, highlighting, things like that. And there are threading rules, so basically be aware of this. And it's useful to have undoable commands because, for example, I've seen cases when I modify document and I modify it in a way that there is no exception and it's not inside undoable command, and it's just like I cannot undo. It's like it's modified. Maybe I need like a local history or something to go back. So yeah, that was the way you can edit actions in IntelliJ, and that's based on pure text, right? So the next step would be to have like awareness of the actual underlying language, and for this reason there are intentions and inspections. So I'll show them in a sec. So I'll unload this. So again, I have some code so that I don't type it for too long. Some code prepared. So if you don't know, there are the difference between intention and inspection. It's easy to show, for example, here. So just some random code from the Gilded Rose cutter. So if I go here and press Alt-Enter, I can see convert to expression body. So it does this. So this is intention because it doesn't highlight anything, or all of these functions, for example, can convert string concatenation to template. So this is an intention because there is no problem with the code. It's just a way to like modify it or transform to some other way. On the other hand, if I do something like this, I do 2 exclamation marks, then the code is yellow, and I can like press F2 to jump to the yellow bit, and it says unnecessary not null assertion. So this is an inspection. It kind of runs in the background whenever you stop typing, and it analyzes code and then highlights that's a problem. Similarly, I can press Alt-Enter, and then it suggests what I can do. It's like the top thing, I think. So what I want is basically to remove it because I don't need it. So that's the difference between intentions and inspections. So to begin with, let's like run this code, and there will be the first thing which I'm adding is an intention. And here what's going on, there is a function called register intention, which is defined in LivePlugin. Well, that's lots of inputs. So it's defined in LivePlugin. Some reason I don't see. Yeah, so it's inside LivePlugin, kind of wrap around IntelliJ API, but the rest of it is literally just like normal IntelliJ code. And there is a base class called PSI element base intention action. I think it's part of just normal intentions. So there are 2 things in there. It's like one thing is one function which we override here is basically saying, is this intention available? So when I press Alt-Enter, should it be available? And it is available based on the project, editor, and the current element in the code. So this PSI element, if you're not familiar, this terminology is basically, like some way you can think it's an abstract syntax tree. So if the current element has parent of KT string template expression, which is like not null, and the text contains OMG, then this intention is available. the interesting thing here is that there is also a declaration that depends on plugin org JetBrains Kotlin, which means that there is dependent on Kotlin plugin. So that's why here we can have this KT string template expression, because this is part of Kotlin. You see here it's like org JetBrains Kotlin PSI, so it's part of classes of like from Kotlin plugin basically. So just to illustrate it, so this is a string with OMG, and I hope it runs because it looks a bit suspicious like it's not running. Let me try it in this file. So if I add a string and I type OMG, it should ideally show something. So yeah, if I go here, it shows replace with cat. So it actually is enabled. So that's the next step. When we invoke it, what it does, it gets the current element text and replaces OMG with cat. And the way it does it is that it has this new text, which is just an element. And basically it replaced, there is a bit of API. I'll explain later. So that's the text of what we see. So when I press Alt Enter, that's replaced with cat. And it has like a family and so on. So it's all kind of configured. So if I do this, it replaces the string with a cat. And again, now it's not available because it's not OMG anymore, this string. So there are a few things here, because how do you even know how to do that? And in reality, I guess the simplest way is to find some simple intention or inspection in Kotlin which you're familiar with and look at the source code. The other thing would be to look at this PSI viewer plugin. So if I go to here, for example, that's not mine. Yeah, I can kind of highlight the code here. I think one of the ways. I think we can go, yeah, I can highlight like this, navigate basically to parts of the code which I'm looking at. That's the bulk body, and I can see, oh, this is how it's defined in Kotlin. That's a property, it has PSI element. Then there is a string template, and not in presentation mode, you can see more details here. So that's how I figure things out. I don't necessarily know how it's all defined. So that's like one way to use plugin like PSI viewer plugin to figure out the structure of the code and then just experiment with intentions. So this is why LivePlugin can be useful, to just experiment with things like that. Well, what's going on here is that we get text of the element, so we have new text, and then we're not doing textual.
It seems we might have lost Dmitry. Yes, so unfortunately Dmitry has apparently lost a connection. So let's wait a bit. We've already collected a number of interesting questions, but I'm afraid that I'm not able to answer them. So there you are.
Yeah.
Okay, please go on. Where you left.
Well, from which point? I'm not sure when everything stopped working. I think it's just
Yeah,
Chrome
so
was hitting.
the point where it stopped working was shortly after you showed navigating the PSI viewer
Right.
window
So,
and talked about the additional properties that we couldn't see.
yeah, so well, that was the end of the demo of intention. So that's how you can do basic demo of intention. So if we go here, we can replace this with cat basically, or here. So it replaces inside longer string. And all I was trying to show with PSI view is that you don't need to be an expert in how like Kotlin code is structured. You can find a code which you want to transform, look at how it's represented, and just figure it out. And this is why I found LivePlugin useful, because you can kind of iterate sometimes a bit quicker than if you create a full project and so on. So that was the end of like intention demo, and the other demo is inspection, like the last demo really. And it's kind of similar. So again, there is a function register inspection, which is part of LivePlugin, but the rest of the code here is just a standard IntelliJ API, because I think it's kind of good enough and easy to use. So similarly, it overrides few functions from abstract Kotlin inspection, which once again comes from Kotlin plugin here. And it creates a visitor, slightly different API. So there is a visitor which basically goes through the tree using this expression visitor function. And for each expression, it kind of does this check. And if it's a string, and if string contains exclamation marks, then it registers a problem. Like basically it remembers that there is something wrong with this expression, and it puts it into problems holder, which is a mutable object. And it says found exclamation marks. And it also provides a quick fix, which basically a way to improve the code, where quick fix is just another class, which is just kind of a function with a name and so on. And it does a similar thing to what we've seen before. It gets the current element and replaces exclamation marks with explosion. And again, it's like PSI factory, create expression, and replace elements. So it's kind of very similar code. This could have been inlined probably. So if I reevaluate this, go back to items, so let's say we do exclamation mark, and it straight away gets yellow. So if I press F2, it kind of jumps and says found exclamation marks. I can press Alt Enter, and it just replaces it with question mark, and I can do the same with cat. So that's kind of similar idea, just two different ways of doing the same thing really. So that's basically it for intentions and inspections. As a summary, there are two functions that register intention and inspection. There is expression visitor, and you can figure out PSI API from other inspections. I guess that's the best way. And use some kind of PSI viewer. There are a few of them. So that's kind of it. There's some final closing thoughts I had, is that if this approach has been around for a while, and if it's better, at least like for some use cases, why is it not that widespread? And I have an idea that maybe it's a bit of like chicken and egg problem, because there is a stereotype that developing plugins is difficult, so people don't even try it that much, so there is not much demand, and IDE developers maybe don't put too much effort into it because there is no demand, and there is no demand because it's still not that easy. So maybe with things like LivePlugin or like similar plugins, this can be moved. And to be clear, it's not that rosy like what I was showing. There are some inherently very difficult problems, like if your plugin has a state which you want to keep between reloads. This can be tricky, because like in Groovy it was easy because it's dynamic language, but in Kotlin whenever you reload it's like a different class loader, and class loaders are the kind of namespaces on JVM, so the classes are not compatible. It's like even if they're identical in memory, they're different class loaders, so maybe you need to serialize, deserialize, which is like its own massive problem. Then not all APIs in IntelliJ are like that easy to use, because they were never designed to be reused, and they were like created 20 years ago. Yeah, 20 years ago, probably. So it's like, to be fair, it's really hard to foresee somebody will be doing something like that with your internal APIs. then there is an inherent problem with all big APIs. When you have lots of different parts of the system, it's just really hard to make navigatable API, and they all evolve over time. So these are genuinely difficult problems in any project. But there is still, I think, like quite a big hope for Kotlin, because unlike other languages, so let's say C++, which has all the editors in the world basically, or JavaScript, Kotlin is somewhat more constrained because there is like IntelliJ IDEA and all like related IDEs with Kotlin support. And of course there is Fleet, but I think it's the same backend as IntelliJ, so maybe it won't be too different. But it could be an interesting idea that it becomes a norm. If you develop a library for Kotlin, you also develop an extension for IDE so that it supports your library better. And it could be lots of small things, but yeah, that could be an interesting prospect to have it a cultural norm within Kotlin community. So yeah, that's the link to the LivePlugin, as I've mentioned before. And this is it really.
Thanks very much, Dmitry. That was a very interesting and quite wide-ranging browsing to all the possibilities that LivePlugin offers to users. And yeah, we've got a number of questions from the stream watchers, and I will just take them in the order they were asked. So the first question we have, I hope I spell all the names properly, from Florian Magin. Is the Kotlin compiler running as a separate process, or is it also running in the JVM?
Yeah, it's running as a separate process. This is why I was showing it separately on slides. And the reason I went for it is because it's more controllable than which Kotlin version LivePlugin is using, because I don't control when Kotlin switches inside IntelliJ. So that's one reason. The other reason is that I think now Kotlin, like IntelliJ and IntelliJ-based IDEs, they come with Kotlin embedded compiler, but I don't think it's always been guaranteed. So initially I just had to bundle it because some IDEs wouldn't have it. So these are the reasons really, to have more stability between IntelliJ releases, and maybe like to have a slightly older version than IDE. And so, but then as long as you stay with the same LivePlugin version, you won't have compilation surprises even if you upgrade. And the other reason is like maybe it will not be bundled at some point. So yes, it is external. It is external.
Yeah, makes sense. Yeah. Okay, the next question, that name is a bit hard to pronounce, from Udlasislaw Kalesnikov. I hope that was close enough. What is the impact on the IDE performance while using the plugin?
I think if you use Kotlin, it adds the whole IDE jar files to one of the indices. That's why you get all the auto-completion without setting up a project. So that will have an impact. If you update, IntelliJ will spend even more time indexing, as if it's not slow enough sometimes anyway. So that will be the impact. Otherwise, there is no impact. It's just there. If you don't use it, it's fine. There is a potential of introducing memory leaks, because it can be very subtle sometimes. So that could be a problem. If you like reload plugin 100 times and there is a memory leak, that would be a problem. On the other hand, just like, yeah, if I get a memory leak once every few hours, I'd rather have that than like restart IDE all the time. So,
yeah. Right. Well, thanks. Yeah. The next question from Tobias Grunwald. Can you still export this as a normal plugin, or also you can share it with others or use it in other projects, or is it bound to the project you're developing in? I think it's possible to share the scripts that you added, right?
Yes, I forgot to show it, but yeah, you can. Short story is that there is this button export. If you add my screen, yeah. Thank you. So there is this button. I actually didn't show a few other things which were important, but there is this button, export. In the release version, you can share it as a gist. So basically, it's like a one file on gist. Actually, you can have couple files here and they will work, so it's not restricted to just one file, although that's pretty much what I've been doing most of the time, having like one file here. So you can share it as a gist, and then you can edit, clone from Git, from gist. There is also a feature which is create plugin zip, which will create a real plugin. It's not released yet. I will release it soon.
Oh,
But you
cool.
can see what happened here. If you want a real plugin, you have to have plugin XML. That's the short story. So it generates one for you. Then it has lots of like to-dos, like do description, and then it just creates a zip file so you can just install it. It bundles with some libraries from LivePlugin, just like not everything, but some bits. But that's it. Like that's a real plugin now, and you can upload it to Marketplace. So these are the two ways of sharing.
Yeah, great. That's actually astonishing news, because I think, especially if you have some project specific or company specific, little scripts that you need to share with your team, that really works very well.
Oh yeah, that's what I was going to show, which I unfortunately forgot to mention. So you can have this thing. That's a project Guild Rose, which has nothing to do with plugin development, but I can do plugin KTS thing here, and if I edit, I can commit it with the project, but then it will become a normal like live plugin. So I say hi, and I can run it from there. So it's inside the project. Then I can go to the settings and of live plugin. So you can also choose to run all plugins on IDE style, but you can also run project specific plugins. So now whenever you open this project, it will run this. I'm not going to show the whole thing, but you can have project specific plugins. So like slowly coming back, that's the third way of sharing live plugins, by basically committing into your project. And this way you will be sharing with all your teammates, and you can have project specific plugins like that.
Which I think would be probably more than enough for most teams who have some kind of utility, whatever, in LivePlugin, which they need to access constantly.
Yeah, I think there is also this setting in project to have like required plugin somewhere.
Absolutely.
This required plugin, so you can add this here. I never really tried this feature on real project, but I have used project specific plugins.
Yeah. But for that, your plugin needs to have an ID and needs to be discoverable via the plugin manager, I think. So then you would need to package it as a standalone plugin, which apparently we will be able to do in the future. So that's a nice thing. One more short notice from me: when you actually package it as a real plugin, there's also the opportunity to host such private plugins locally in your network if you want. We have some description about that in the SDK docs as well, so you can simply run an HTTPS server which you can share in your company to distribute such internal plugins. Right. So yeah, I think these are very good to hear news about this whole topic. And then there is another question from Valentine Cruz. Is it possible to modify code of already installed plugin? I'm not really sure what already installed plugin really means here.
Right. Yeah, that's a good question, because maybe I should have maybe showed that in Hello World example, you can do like show plugin path, and it really shows you that's the folder. And all there is to it, the Hello World is just a directory on this path. And inside there is a plugin. There's a file called plugin.kts. By convention, that's the entry point for all plugins. So they are distributed via source code, and you can modify it anytime. So when you modify it, you rerun it, and that's it. So with live plugins, all it means, installation means just create a file in this folder. The important thing was also it's all under specific like live plugins inside IntelliJ setup. That's like a special folder. Anything under this folder, if it has a plugin.kts, a plugin.groovy, it will run. And that's all it means to install. And it's distributed via source code. So if you modify source code, the plugin is modified.
Thank you. There's another question from Ulatsislaw. Do I need to install or configure something else but the plugin? I don't think so, really, right? I mean,
No,
mm,
no,
so
just
it comes,
LivePlugin. That's right.
yeah, it comes with all dependencies, as you mentioned. You bring
Yes.
your own Kotlin compiler and everything. So
Yes.
it works in any IntelliJ-based IDE. Obviously, the available API might slightly differ because they bundle different languages and frameworks which you can or can possibly use in your live plugin. So obviously Kotlin is not available in WebStorm or some other small IDEs, but all the other basic functionality, of course, you can use in any IDE.
Yeah. I think they still highlight a bit of like Kotlin. There is some very basic parser, so it will still look better than just black and white text. So, but yeah, there is no auto-completion, nothing like that. Yes.
True. Yeah, that is also the effect of missing Kotlin support inside the IDE in which you are actually developing the live plugin at the moment, right? Yeah, that is another aspect. Yeah. Then there is another question from Gian Ui, I hope. Can we set up a plugin repository in Artifactory? I think that's more of a general question about distributing plugins. The short answer is I'm not sure, but I'm 99% sure you can't because you really need to have this plugin XML updates file which contains all the metadata which the IDE needs to understand and parse to show you what kind of plugins are available and whether or not they are compatible with your current IDE from which you are trying to install and manage them. So Artifactory or any basic artifact sharing server will not be enough. You need to have this XML file. There's some tooling around that as well. So possibly you could store the zip artifacts of the plugins in Artifactory and point to them via this update XML file. That should probably work because it doesn't really matter where the physical plugin file is stored, but you will need this XML file for metadata for the IDE to consume.
There is a function called like the action install plugin from disk, right? So
yes.
You could write a plugin which downloads them from Artifactory and like make sure they're in sync, and if they're not, it just installs them. So that's a way to like figure it out through live plugins.
That would be a possibility, yeah. But I think the other options we showed are probably more interesting for most people, especially in a project or company aspects. When you want to share such specific scripts or mini plugins that you can create and maintain using LivePlugin. So as far as I see, we have answered all questions and we have actually filled our time slot for today. So once again from everyone and as also from the IntelliJ SDK team, a big thank you to Dmitry for being here with us and sharing his live plugin and showing us all the great possibilities on what is possible. And I think it's really a good solution if you need some small automation that are maybe even specific to your team or to some technology that you use in some project. That certainly is much easier to achieve and distribute inside your team using LivePlugin than writing and maintaining the full plugin and going through all the necessary steps to even write the first line of actual business code in your plugin. Just go ahead and script it in the IDE. That has really a lot of advantages. So again, thanks from everyone, Dmitry. It was very nice to have you as our guest speaker today, and we look forward to further improvements on LivePlugin.
Yeah, thank you.
Thank you all, and see you in the next episode of Busy Plugin Developers. Stay tuned.